APG Pathshala, subject Computer Science, notes Data Structures. So, welcome to this lecture on data structures. This particular study note is from APG Pathshala site, MHRD, Government of India. So, I would like to express my sincere gratitude to them. Though most of you would have studied data structure in this course, we will be looking at data structure from a new perspective, this perspective of abstract data type. Before we understand the concept of abstract data types, let us re-look at programming, which is essentially problem solving using a computer system. However, through computers today are used to solve very complex problems. Programming is not magic. The maxim remains that you cannot make a computer to do something if you do not know how to do it yourself. Before you start programming, you need to understand the problem. Some of the important tips are: find out as much as you can about the problem by taking to the problem presenter as far as possible. Reuse what has been done before and design the program expecting future reuse. The first step in understanding the problem is breaking the complex problems into subproblems and then trying to determine what previous attempts at solving this problem or similar problems have succeeded and what attempts have failed and why they have failed. In order to appreciate the concept of abstract data types, we must first consider some important design principles. There are some principles that are to be followed when designing a good program. These include abstraction, encapsulation, modularity, and hierarchy. Let us consider each of the principles one by one. Abstraction. Here are two general definitions of abstraction. Abstraction arises from a recognition of similarities between certain objects, situations, or processes in the real world, and the decision to concentrate upon those similarities and to ignore for the time being the difference. An abstraction denotes the essential characteristics of an object that distinguish it from all other kinds of objects and thus provide crisply defined conceptual boundaries relative to the perspective of the viewer. In other words, abstraction is also described as the purposeful suppression or hiding of some details of process or an artifact in order to bring out more clearly other aspects, details, or structures. In the context of programming, the use of abstract data types, which we will discuss later, or the use of objects encourage abstraction. The principle of abstraction can be described as the process of determining the relevant and essential properties and features of an entity or what we call an object, while ignoring non-essential details with respect to the way the entity is implemented, and also focused on obtaining interfaces outside view of objects. Moreover, relevant properties are defined by how the entity is to be used and manipulated. For example, an auto salesperson views a car from a standpoint of its selling feature, while a mechanic views the car from the standpoint of the systems that require maintenance. Then encapsulation. Here are two definitions of encapsulation. Encapsulation is a process of compartmentalizing the elements of the abstraction that constitute its structure and behavior. Encapsulation serves to separate the contractual interface of an abstraction and its implementation. Encapsulation is a mechanism used to hide the data, internal structure, and implementation details of an object. All interaction with the object is through a public interface of operations. Encapsulation is a mechanism by which we restrict the access to some of the object's component as well as binding the data and methods operating on the data. The principles of encapsulation can be described as the separation of objects based on external and internal aspects. In other words, only the external aspects of an object need to be visible to other objects of the system, while the internal aspects are details that should not affect other parts of the system and need not be visible to them. Encapsulation is a technique for packaging the information in such a way as to hide what should be hidden and make visible what is intended to be visible. That implementation details. Hiding the internal aspects of an object essentially means that they can be changed without requiring changes to other system parts. Hierarchy. The principle of hierarchy can be described as a and useful way of ordering abstractions from the most general to least general based on some relationship between them. Hierarchies can help us understand complex objects. Hierarchy makes all the abstractions easier to understand because it exposes the relationship of the characteristics and behaviors they have in common. An example of a management hierarchy is shown here in this picture. You saw that, and which is based on to who reports to who. A specific type of hierarchical order based on natural relationship is called a taxonomy. An example of taxonomy is that of musical instruments that organizes instruments by how they produce their sound. Before we define abstract data types, let us recall the description of traditional data structures. Let us recall the description of data structures. Data structures are a systematic way of organizing and manipulating data. In other words, a data structure structures data, usually more than one piece of data, and should provide legal operations on the data. There are aspects of data organization and functions for manipulating data. Data structures are conceptual and concrete way to organize data for efficient state storage and manipulation. Data structures are basically used in the implementation of efficient algorithms. Important data structures. Before we begin discussing the details of abstract data types, or ADT as they are called, let us list some common linear data structures, some of which we will study later on from the perspective of abstract data types. These include fixed size arrays, variable size linked lists, stacks where we add to top and remove from top, queues where we add to back, rear and remove from front, and priority queue where we add anywhere but remove the element with highest priority. Next, we go on to discuss the concept of a data type. Before go on to discuss the details of abstract data types. What is a data type? Data types are associated with a set of entities or objects and a set of operations. Each object is called an instance of the data type. Some of these objects are sufficiently important to be provided with a special name. Operations can be realized by operators, functions, procedures, methods, and special syntax depending on the implementing language. Of course, each object must have some representation, not necessarily known to the user of the data type, and each operation must have some implementation, also not necessarily known to the user of the data type. Data types are basically of two types: opaque data type and transparent data type. Opaque data types are data types in which the representation is not known to the user. Presentation can be changed without affecting the user, since these data type encapsulate the operations. Without encapsulation, you cannot have opaque data types. This forces the program designer to consider the operations more carefully and allows less restrictive designs which are easier to extend and modify. Design is generally carried out with the expectation that the data type will be placed in a library of types available for everyone to use. Transparent data types and are data types in which the representation is profitably known to the user. The other words are encoding. Other words, the encoding is directly accessible and are modifiable by the user. This allows the user to manipulate the data types because the representation is known to the user. In the next section, we go on to discuss abstract data types. Abstract data types, concept of abstraction. Let us first recall the notion of abstraction. An abstraction is a view of representation of a data type that include only the most significant attributes. The concept of abstraction from this viewpoint means you know what a data type can do, but the details of how it is done is hidden. The concept of abstraction is fundamental to programming. Programming languages generally have supported process abstraction in the form of subprograms, and some of the more recent programming languages do also support data abstraction. In simple terms, the data abstraction, what you can do with the data, is separated from how it is represented. Data abstraction or abstract data types is a programming methodology where one defines not only the data structure to be used but the process to manipulate that data structure. An abstract data type is one that is defined in terms of the operations that it supports that can be performed upon it rather than in terms of its structure or implementation. An abstract data type is a user-defined data type that satisfies satisfies the following two conditions. The first condition is that the representation and operations of the type are defined in a single syntactic unit. The second condition is that the representation of the type is hidden from the program units that use these objects, so that the only operations possible are those provided in the data type's definition. Then advantages of data abstraction. Now let us look at some advantages of data abstraction. The advantage of the first condition of data abstraction, knowing what a data can do, is better program organization, modifiability, everything associated with the data structure is together, and separate compilation. The advantage of second condition, representation is hidden, is reliability, because by hiding the data representations, user code does not depend on the representation, thus allowing the representation to be changed without affecting user code. Abstract data type, or ADT. Some data is associated with a set of operations, and mathematical abstractions have been an integral part of programming language. Abstractions which we have been using without giving it much thought, like integer, boolean, etc. The basic idea ADT is a logical view of the data objects together with specifications of the operations required to create and manipulate them. Designing and coding an ADT once enables the reuse of the ADT. Some changes in the implementation are transparent to the other modules. Just like an algorithm is described using pseudocode, a data structure can be described using ADT. The meaning of abstract in Latin means to pull out, and in our context, abstract essentially means to pull out the essentials and to differ to hide the details. In other words, abstraction emphasizes essentials and differs the details, making engineering artifacts easier to use. ADT can be described as follows: declaration of data, declaration of operations, encapsulation of data and operations. Summing up, ADT is a type of encapsulating related data and is abstract in the sense that it hides distracting implementation details. Now, what are the programming language that naturally support ADT? Objects are a perfect programming mechanism to create ADT. Given below are some examples of ADT. Set ADT, a set of elements, operations, union, insertion, intersection, size and complement. QADT, a set of sequence of elements, operations, create, empty queue, insert, examine, delete and destroy queue. A very important point to be noted with respect to ADT is that two ADTs are different if they have the same underlying model but different operations. Thus, for example, a different set of ADT can be defined with only the union and find operations. It is to be noted that the appropriateness of the implementation depends very much on the operations to be performed. Need for ADT. As we have already discussed, ADT allows implementation to be changed without violating ADT definitions. ADT provides us a standard list of structures to use and study. They give us building blocks and tools which are conveniently be used by programs. ADT is the foundation for the design of object-oriented programming language like C++, Java, etc. They adopt concepts of abstraction, encapsulation, modularity, hierarchy, which comes with their own advantages. Primitive DT, programmer, INT, float. Abstract DT, programmer interface, implementation methods, data. Pros and cons of ADT. Now let us list some of the advantages of the use of ADT. One of the important advantages is that implementation of the ADT is separate from its use. By design, ADT is modular and we can design one module for one ADT. ADTs are easier to debug and also make it easier for several people to work simultaneously. The code written for an ADT can be reused in different applications and it allows the concept of information hiding. Logical unit can be designed to do a specific job and implementation details can be changed without affecting user programs. All the above advantages allows rapid prototyping since the prototype can be designed with simple ADT implementations, then turned later when necessary. One of the disadvantages of ADT based design is the loss of efficiency since the representation and implementation details are hidden and the knowledge of these details cannot be exploited to improve efficiency. Basic concept of ADT. Let us revisit some of the concept of abstraction like modularity. The first concept we will discuss is the concept of modularity. Modularity keeps the complexity of a large program manageable by systematically controlling the interaction of its components. It helps to isolate error and eliminate redundancies. A modular program is essentially easier to write, easier to read and easier to modify. Then information hiding. The next concept we discuss is information hiding. ADT hides the implementation details of the operations and the data from the users of the ADT. In other words, makes these details inaccessible from outside the module. Users can use the operation of an ADT without knowing how the operation is actually implemented. Examples include a deck of playing cards and a set of index cards containing contact information and telephone numbers stored in your cellular phone. Data abstraction. The most important concept of an ADT is data abstraction. It asks you to think what you can do to a collection of data independently of how you do it. It allows you to develop each data structure in relative isolation from the rest of the solution and is essentially a natural extension of procedural abstraction. Then encapsulation. In the context of ADT, encapsulation allows operation on an ADT only by calling the appropriate function. There will be no mention of how the set of operations is implemented. In a sense, the definition of the type and all the operations on that type can be localized to one section of the program. After this point, we can treat the ADT as a primitive type since we are no longer concerned with the underlying implementation. Design of abstract data type. The first step in the design process is the specification and the problem, where the design of an ADT should evolve naturally during the process. The questions to be asked while designing the ADT are the type of data the problem requires and the associated operations required. For complex abstract data types, the behavior of the operations can be specified using axioms. An example of axiom is given. A second step in design is the development of a real or imaginary application to test the specification. Missing or incomplete operations are found as a side effect of trying to use the specification in the application. The third and final step is the implementation of the ADT, where we can decide on the suitable representation, implement the operations, and finally test, debug, and revise the code. Typical operations on abstract data types. Before we complete this module, we will look at some typical operations that will define ADT irrespective of the type of ADT. This include creating a data collection, adding data to a data collection, removing data from a data collection, and asking questions about the data in a data collection. Create operation. It is always necessary to create an object before it can be used. For example, in Java, this is done using the class constructions. The availability of this operation depends on the particular ADT. In many cases, it is not needed or desired. If present, the meaning of the operation also depends on the particular ADT. In some cases, copy means make a true copy of the object and all its data fields and all their data fields and so on. And in other cases, it may mean to simply make a new reference to an object. In other words, the reference to the object is being copied, not the object itself. In this case, there is only one object and is shared among all the references to it. This makes sense for objects that occupy large amount of memory and in many other cases as well. Both types of operation can even be included in the same ADT. In some languages, the copy operation can have explicit and implicit versions. For example, in Java, the implicit operation defined by assignment or method argument passing always copies reference, but it is possible to make other kinds of explicit copies using a copy constructor or by overriding the clone method inherited from the object class. Then destroy operation. Since objects take up space in memory, it is necessary to reclaim the space when an object is no longer needed. This operation is often called the destroy operation. In Java, there is no explicit destroy operation since the built-in garbage collection takes on this responsibility. And there is no more references to the object, it is eventually garbage collected. Modification operations. Every object of an ADT encapsulates data, and for some ADTs, we need operations that can modify this data. These operations act on objects and change one or more of their data fields. Sometimes they are called muta operations, I guess. Yeah. If an ADT has no mutata operations, then the state cannot be changed after an object has been created, and the ADT is said to be immutable, otherwise it is mutable. Then inquiry operations. An inquiry operation inspects or retrieves the value of the data field without modification. It is possible to completely hide all or part of the internal site of an object simply by not providing the corresponding inquiry operations. Preconditions and post conditions. When working with ADT, preconditions and post conditions effectively clarifies and documents your thinking process. In addition, the operation definition along with the pre and post conditions supply all the information required by others to utilize the interface of the data type. In other words, specifying what this operation does along with the pre and post conditions enable procedural abstraction and important concept of ADT. Precondition statement or a set of statements outlines a condition that should be true or conditions that should be true when the operation is called. The operation is not guaranteed to perform the way it should unless the preconditions have been met. In other words, had post condition statement or statement describe the condition that will be true when the operation completes its task. If the operation is correct and the precondition has been met, then the post condition is guaranteed to be true. In addition, the operation is also associated with invariants that specify properties of the ADT that are not changed by this operation. Let us assume that the operation is specified as a function. Preconditions usually focus on the inputs to a function, while post conditions usually focus on the output of a function and any side effect. The type of specification where preconditions and post condition is specified exactly known as programmed by contrast.